Hi everyone, my name is Allisaib and I'm a master's student with the Minerals to Metals Initiative at the University of Cape Town. Today I'll present you my research topic, which is titled Determining the Contribution of Emissions of Listed and Unlisted Activity from Mining and Metallurgical Activities in Turana Bay, South Africa. This theme of NXGEN is called Mine Life Cycle. The life cycle of mining begins with exploration, continues through production, and ends with the closure and post-mining land use. The beginning of any mining project begins with the exploration stage. This is where we try to understand the geology of the land in search of mineral deposits. This is achieved through geophysical and geochemical surveys. Mine development stage includes the feasibility, geoscience, and engineering studies, while the production phase includes the extraction, milling, and processing of raw materials such as coal, metals, and industrial minerals. The last stage is mine closure and the protection environment, which starts at the beginning of the project and continues after the closure. Dust is broadly defined across literature as particles suspended into the atmosphere. According to the Glossary of Atmospheric Chemistry terms, dust is defined as small, dry, solid particles suspended in the air by natural forces such as wind, volcanic eruptions, and man-made processes such as crushing, grinding, shoveling, conveying, bagging, and sweeping. Dust particles are usually in the size range from 1 to 100 micro in diameter, and they settle slowly under the influence of gravity. The four subclasses of dust that affect the environment are generated dust, total suspended dust, Newton's dust, and fugitive dust. Fugitive dust is dust that is generated from multiple or undefined sources, and fugitive dust poses as one of the major problems in mines due to its generation from unconfined sources. Mining is one of the world's largest and dominant industrial sectors. It has provided the world with many innovative technologies and products, ranging from electronic devices that we are dependent on to the fertilizers that help us have food all year long. South Africa's mining sector is ranked the fifth largest mining industry. It has 90% of global platinum group metals reserves, as well as mines as deep as 3,000 meters. We mine over 50 different types of minerals, in which our top three exports are platinum, coal, and gold. What is the problem? In recent years, the Turana Bay has become an industrial hub recognized for mineral processing activities and the transportation of mineral ores. Due to the industrialization, there has been a notable increase in mineral dust and particulate matter in the area. The emission of these air pollutants is of great concern to the surrounding communities for health reasons, as well as the potential effects on the ecological environment. I hope my research can help identify the emission sources and assess the current air quality in Turana Bay. The outcome of the study could provide useful information for the emission inventory on a regional scale and contribute to technical reports that estimate the total emissions, as well as predict emission trends in Turana Bay. This study could potentially provide substantial evidence that allows stakeholders and government officials to assess the current emissions and make educated decisions on air quality legislation and policy-making strategies to reduce the impact of air pollution. The overarching aim of this study is to investigate the environmental and health impacts of particulate matter emissions in Turana Bay. To gain a thorough understanding of air pollution from industrial activities in Turana Bay and its impact on the surrounding environment, the following proposed objectives have been formulated. The first objective is to identify pollution sources and evaluate the contribution of listed and unlisted activities to the current concentration levels. The second objective is to generate dust from metal ores in a lab-based setting and determine the emission factor And the last objective is to conduct atmospheric dispersion modeling of the emission inventory. My research was designed to address the air quality in Toronto Bay. The first method is sample collection, which will be achieved through passive and active gas sampling and obtaining metal ore samples from various mines, as well as generating dust from metal ore samples in a lab-based setting using a stationary wind tunnel. The second method is the categorization of particulate matter, which will employ different analytical methods used to determine the composition, particle size, and mineralogy of particulate matter. The third method is to compile an emission inventory to keep a record of the type of pollution, the location of the emission source, and discharge rate of emissions, which will allow for active and accurate dispersion modeling. Lastly, my fourth method is dispersion modeling. This is an effective tool used to estimate the pollution concentration for various emission control scenarios and determine the dispersion potential of pollutants emitted from various emission sources. What do I hope to achieve from this research? Dust generation from metal ore samples in a stationary wind tunnel will produce emission factors that will serve as valuable data to use in emission inventory. Based on the mineralogy, composition, and particle size of particulate matter, this will help identify the potential impact in terms of the environment and public health. The emission inventory will help identify all air emissions of small-scale industries that go undetected by the municipality and not held liable for their emissions above threshold. Finally, dispersion modeling will help identify the vulnerable communities that are affected by the release of emissions. Development Goals was an initiative created to eradicate poverty, ensure a safe and clean environment, and promote sustainable economic growth. The improvement of air quality will play a crucial role in achieving the purpose of these goals. Reducing air pollution in Sedona Bay would ensure healthy lives and promote well-being for all at all ages. Cities are vulnerable to climate change and natural disasters due to their high concentration of people and air pollution due to urban heat islands. If annual levels of fine particulate matter are not reduced in cities, this will affect the public's health, which has a ripple effect on the workers' productivity, result in economic loss, and a disruption in everyone's lifestyles. Mining has played a significant role in the economic growth of the world. However, the economic and social progress over the years has been accompanied by the destruction of the environment. Therefore, it is important that we promote sustainable development. High concentration of pollutants. The atmospheric environment has changed drastically. This is one of the factors that play a role in climate change. Pollutants do not stay in the atmosphere, but can also be deposited into the ocean. This alters the natural chemistry and disrupts the ocean's ability to absorb carbon dioxide emissions, which help mitigate the impacts of climate change. Acid rain is a result of air pollution. This has a negative effect on the environment in terms of damage to vegetation and altering the soil chemistry. This concludes my research. Thank you so much for listening.